Assalamu alaikum. I'm Mr Fayaz Ahmad kuchay. Today my topic is deflection torque produced by PMMC. Lastly, I have discussed class 12th that in PMMC I have discussed the principal working of PMMC, permanent magnet moving coil instruments, principal working and construction I have already discussed. Now today I may discuss about the deflection torque. Deflection torque. Torque is a kind of force which I have told you already, that the force which is created by the rotation of the coil, rotation of this coil with in between magnetic field and the electricity of this winding coil. A torque force is being produced here. That torque force, deflection torque force, I am discussing here. So the torque force which is produced by this by the rotation of that winding coil through which the current is passed, and the torque which is produced between the magnetic field produced by this magnet and the current which is going through the winding coil. So what, dear students, you have to keep in mind, I am writing here in coil of carrying current I ampere. Then we have got force on the coil, the torque on the coil, force on the coil, that is equal to B into I into N, or force F is equal to B into I into L newtons N. Now let me tell you, the TD represents deflecting torque. Deflecting torque is equal to F into R. That's equal to, what's the F? F is the force into, what's the R? R, we can say, R is the distance between center of the coil and force F. R is the distance between the center of the coil, or the distance between the center of the coil, this coil which is rotating, or the distance between the center of the coil, or the distance between the center of the coil. Here we can say it is being the radius of the coil taken into account. So F is equal to P into I into L. What's L? L is the length of the coil, length of the winding coil's length. L is the length of the coil, which is taken into Newton N. So deflecting coil TD is means deflecting torque is equal to force into radius of the coil, which is taken from the center of the winding coil. That's equal to B into I into L into M into R. What does that mean? What is the B? B is the flux density. B is the flux density in the air gap. Flux density in the air gap. That means when you have got winding coil, the flux density means the gap which is produced between the two winding coils, the two wiring wires. The gap which is produced between that is known as flux density in the air gap. That is taken into WB Web per meter square, its area. What is L? L is the length of the vertical side of the coil. Vertical side means this side, vertical side of the coil. This is the same D Orson-Welles moment. It's known as D Orson-Welles moment. The question may be asked as describe the D Orson-Welles moment. D Orson-Welles moment instrument, or it can be asked as describe PMMC instrument. It can be asked as PMMC instrument or as D Orson-Welles moment coil or instrument. So TD means deflecting torque is equal to force into radius of the coil, that's equal to B into I into L, that's equal to this. So simply L, I have told you, L is the length of the coil, length of the vertical side. Vertical side means this vertical. This is being horizontal. If you take it from this position, this is being vertical side of the coil. So L is the length of I is the current. I is the current in the movable coil. So what is the B? B is the air gap. Air gap. B is the flux density, air gap between the coils. So deflecting torque dt is proportional to I. That will be proportional to I. This is the equation first. Deflecting torque is simply proportional to I. So again I may tell you then I'm discussing controlling torque CT, or we can call it TC, controlling torque. That is, we say proportional to theta. What is theta? Theta is the deflecting angle. Theta is the deflecting angle. Theta is the deflecting for equilibrium. Equilibrium means when we are taking the rest position of this coil, we will have control torque is equal to deflecting torque. So when you substitute the two equations, that equation first and equation second, you will have theta is proportional to I square. Why is it I square? Theta is proportional to I square. It's I square because the current flows through two ends of the coil. Current is flowing through the two ends of the coil. Current is flowing through two ends of the coil. Through two ends of the coil means one side naturally will be one side from this way, second side will be from this way. The current is flowing from both the sides of the coil. That's why we are taking here theta, deflecting angle is proportional to I square, current square, as the angle of deflecting is directly proportional to the square of the current, that is theta is equal to I square. That is theta is equal to I square. That's why we are taking theta is proportional to I square. So this was the relation. This was the mathematical relation for controlling torque, or we can say deflecting torque, which I have discussed here. These are the mathematical relations. If you have any doubt, you can call me. I have already, my number is already being with every student. You can call me if you have got any kind of problem in this question. This question is very important, being asked every year. So kindly write down it. I may focus it again. I have already focused it last time. I may focus it on this mathematical deflecting torque. You see what I am writing here. Again, I may focus it here, so you can get clearly written this note, and then you can remember it. Just the equation first. Deflecting torque. This is controlling torque, that is equal to controlling torque is proportional to theta. Equation number second. Then we are in equilibrium comparing these two. Then theta is proportional to I square. Okay, assalamu alaikum. That will do for today.